Welcome back to Pepcoding, guys. And in this video, we will be discussing our question add last in linked list. So input and output is already managed for you. You just have to write the add last function, and that's it. So let's see what you have to do in this question. So for example, in a stack, you have a linked list at 4K address, right? So this is the address 4K, and the head of this linked list initially is none. The tail is also none, and the size is 0. So if we say that add 10, so you have to add at last. That means, what does it mean? That you have to create a new node and with data 10, and you have, for example, it is created at 5K. So if you only have to add one node, what you have to do, you have to make the head and tail as that node only. So what you will do is your head will become 5K and your tail will also become 5K, and the size will increase by 1. Now if we say that add 20, so what you'll do is you'll create a new node with data 20, and which for example it is at 6K. So now your previous node is pointing at 6K. That means in your previous node, in the next part of your previous node, there is 6K present, right? And now your tail becomes this. Your new node becomes your tail. That means your tail becomes 6K and you increase your size by 1. This is it, and that's it you have to do. So try it yourself, and then we will discuss the solution of your add last and linked list question. So I hope you tried it yourself. Let's discuss the solution. So in this question, I already explained what you have to do. Let's discuss it once more. So initially in stack, there is a linked list at 4K with head none, tail none, and size 0. And we are adding 10 in this linked list, which does not have any nodes. So what we do is we create a new node, right, with data 10, and we make our head as this node, right? For example, this node is the address 5K. So our head becomes 5K, our tail becomes 5K, and we increase our size by 1, right? Now, if we have to add another node in it, we have to add 20, and we have to add it last, right? So the first node will be pointing to our new node. We'll create a new node with data 20, and how we'll do it, that is, if this is at 6K, what we'll do, initially our tail was 5K because we only had one node. So what we did, we saved this in our node named last. We save our tail in it, and at last dot next we create a new node. Last dot next, in the next part of, we created a new node. This is the new node, right? And what we do is we make our new node, that is last dot next as our tail. So we change our tail by last dot next, and we increase the size. So in this question, what we are doing is we are creating a new node, then we are making it our tail, make tail, and increase size. That's all that we have to do, right? We increase the size by 1 because we are adding a new node. Let's try to code this. Okay, so we just have to write the add last function, right? What we will do is, first of all, we will create a new node. New node is equals to node with new data, right? We created a new node. Now we will check if our self.head is none. If our self.head is none, that means our linked list does not have any nodes. So what we'll do is we'll make our head as this new node. We make our tail, self.tail, our new node, our new node becomes our tail as well as our head, and our self dot size increases by 1, and we just return. Else what we'll do is we'll store our tail, self dot tail, in a node named last, right? Because we have to add it last. So we save our self dot tail in last, and we create a new node at last dot next. At last dot next, we create a new node, right? And what happens now is our say self dot tail becomes our last dot next, right? And we increase our self dot size by 1, and that's it. This is it. We created a new node. We checked whether our head was none. If our head was none, we made our head and tail the same node, and we increased the size. If our head is not none, what we did was we created a new node at next of our tail, right? And we made our tail our new node, and we increased the size. Let's try to run this, and it should work fine. Yes, it is working fine. Let's submit this, and it is the correct answer. So I hope you like this video. Make sure to subscribe to our Pepcoding channel, and thank you for watching. I'll see you in the next question.